Thank you, everyone. Glad to be here today and glad to see you all. So I'm Hannah Amiri, and today we're going to be talking about something that probably shaped all of our work and sometimes all of our pain as well. You build it, you run it, or you build it, you cannot run it. I gave a draft of this talk internally, like very briefly, and it sparked a lot of debate. I got everything from angry DevOps engineers to people actually agreeing with the message. So I would be curious to have your opinions afterwards, so don't hesitate to come talk to me after this. I get it, though. I mean, you build it, you run it is something that was supposed to be very empowering, and it promised us autonomy, it promised us speed and ownership as well. So who am I to be saying you build it, you cannot run it, right? So I'm a lead system architect. I've spent the last 10 years wearing multiple hats as a developer, a consultant, a platform lead, an architect as well across different companies with different sizes and different experiences. I currently work at a company that is called Sonepar, if you heard of it. For those who didn't hear about it, it's a company that keeps the lights on, like literally. It's a global electrical group that distributes electrical products across the world. And today it's building platforms that serve millions and millions of electricians and suppliers and also a lot of industries in the world. In my previous experiences, I observed the same struggle a lot. Everyone is happy with you build it, you run it, until we actually start to scale and we hit a certain size and things would start to become very messy. So who here operates in your build it, you run it today? Please raise your hands. Okay, that's very reassuring. All right, keep your hands up if you actually think it's working perfectly for you. Oh, okay. That drastically reduced. Cool. Let's rewind to the beginning. So getting back to the start or the origin of things would actually give us a better understanding of where we are today. You build it, you run it was first introduced by the Amazon CTO in 2006 in response to the operational in response to the operational bottlenecks that was created by the traditional separation between devs and ops. That was the beginning of the cultural shift and the groundwork for DevOps, the DevOps movement. Now I know that some of you are probably asking this question right now. You build it, you run it is not the only flavor of DevOps. I think we all know that, but it's the one that shaped most of what came afterwards. Yeah, so in 2009, the first DevOps Days, if you remember the conference, was brought to life, and it brought these communities of devs and ops together. And was also recognized by the early Agile practitioners. The goal was to bridge the gap between the developers and operations and help deliver faster and more reliable software, if it was done right. However, a lot of companies focused on building and automating CI/CDs and tooling rather than actually bringing these teams together. So while the automation, the CI/CD, the tooling improved, the provisioning of infrastructure was still a huge problem. And this is where in early 2010s, to remediate this, the configuration management tools became mainstream and allowed to automate infrastructure via code. This added a multitude of tooling, if you remember, all those illustrations and images of the DevOps landscape and the ecosystem, and managing the increasing code base and the dependencies of writing those codes became way far complex. few years in, and we witnessed the era of cloud computing and the on-demand resources. I skipped a few things, if you noticed, because otherwise it will be like 3 hours long. This accelerated delivery, but also introduced a lot of challenges like networking that became way too complicated, deployments, observability, especially for teams that were not used to distributed systems and on-demand environments. So then we got the arrival of Docker as well. That was revolutionizing how the applications were packaged and deployed, feeding into the microservices architecture. But managing too many microservices at scale became way too challenging for the companies. In 2015, Google open sourced Kubernetes as a response to that, and as a orchestration platform, container orchestration, and it quickly became the standard for microservice architectures and for deploying microservices. So containers and Kubernetes became the standard to enable scalability, consistent environments, and many other advantages. But they added way more complexity in the you build it, you run it model, especially for the fact that Kubernetes was not very developer friendly, if you remember, especially at the beginning. Well, it is a bit better now. Few years later, and we witnessed the arrival of developer-friendly infrastructure as code. So tools like Pulumi, like AWS CDK, were an attempt to let engineers use familiar programming languages to actually define and provision infrastructure. And it aimed to improve the developer experience in actually writing infrastructure as code. However, while they lowered the barrier to actually provision the infrastructure, they still didn't solve any of the underlying complexity that comes with managing microservices at scale. And around the same period, DevOps started to grow, and new paradigms started to emerge to actually respond and address this growing complexity. It was about time. DevSecOps, for example, brought security into the DevOps fold with security shift left. GitOps was applying Git-based versioning to ops and promised us consistency and auditable ops, for example. But it also introduced its own learning curve for the developers. And then SRE was introduced by Google in 2016. And it was formalizing approaches to keep systems reliable. And it turned operations into an engineering problem. So they brought ops expertise closer to the developers with shared languages like SLIs, error budgets, availability targets as well. And many of the organizations started to actually push to use SRE along with DevOps, often further blurring the roles between both of them. If you remember, around that time, there was a lot of articles about what is the difference between SRE, between ops, between DevOps, and all of that. In March 2020, recently, well, 5 years ago, Spotify open-sourced Backstage. As an attempt to tame the growing complexity and the cognitive load. These internal developer platforms standardize how developers approach infrastructure and interact with infrastructure and the services around it by offering a central point of entry through a portal or through a catalog to mend those siloed knowledge and those fragmented tooling and reduce the cognitive load around it. But, as you guess, it did not eliminate the difficulty with distributed systems and microservices architectures. So do you see a pattern here? I actually see two patterns. The first one is mostly visible before 2016 or 2018, where every time we had an operational challenge with a new paradigm or with a new pattern, the industry's answer to that was, hey, here's a new tool that you can use for that. And I'm not saying these tools were not beneficial for us. I think each one of these tools in isolation was very powerful, but together they created a huge maze for the developers and they added too much cognitive load for them. And it also set the scene for the second pattern that I see. The second one is very natural to IT and to tech in general. We love doing this. We love creating complexity and solving complexity by adding more complexity. And this actually pushed more operational burden to the developers. And many of these teams found themselves struggling with cognitive overhead and trying to understand and implement security by design, observability, infrastructure, containers, you name it. So we ended up with something very ironic. You build it, you run it, that was supposed to be something that would bring autonomy to the teams and speed, became the huge cognitive tax to the developers. Because you build it, you run it, if you look at this, it takes into account two major factors, feature criticality and feature demand. So if you think about an HR system, for example, HR systems usually are not highly critical to the company and also don't require too many changes on the long run, doesn't require too many features. So this kind of system is better off with you build it, ops run it model. However, if you look at the reality of our products today and our software development, speed is becoming super important, and 80% of our products today are using the you build it, you run it model. The complexity made this idea very, very complicated to implement, and the teams who used to be supposed to build it and run it are now building it and wanting to run away. Nobody wants to do on-calls anymore or handle anything in production. So why is it broken? Because teams today would spend around 60% or 70%, I'm not making up the numbers, of their time on actually working on the operational toil of delivery instead of actually delivering value. So, for example, they would spend a lot of time deciphering Kubernetes logs or trying to make sense of deployment issues, which was not the objective from the beginning. It also blurred the lines and boundaries between the teams and fragmented the whole ecosystem based on the tools and based on the tech stack. So these two options were not enough, and many organizations started to realize that just pushing you build it, you run it was not enough, and it was not sustainable at scale. So big companies like Google, Netflix, Airbnb, I think as well, started to build internal platforms for their teams to move faster. In 2018, I think, the term digital platform started to reemerge or reappear because it was not something new, it's an old concept, but it was repurposed this time for the concept of platform engineering. And platform engineering arose as a response to actually to respond to the pain points and to be DevOps next evolution, or essentially DevOps at scale, and focused on actually solving the problems that DevOps couldn't in large and complex environments. So if DevOps is about empowering teams to deliver faster and to shift left operational responsibilities, the platform engineering was about making that shift sustainable at scale. And to do that, we opted for what we call a shift down of these responsibilities to the platform team. So the platform team would build shared platforms or shared tools, which is a set of APIs, interfaces, for example, or services that would encapsulate or abstract away the complexity of infrastructure and the different services needed for operation, making it easy for the developers to operate their services and to build their services as well. It works for both. And gluing together and centralizing all these fragmented tooling that would lower the cognitive load on the developers. So how does it do that? A fundamental trait of a good platform is that it enables developers to get what they need on demand and without filing tickets, like we used to do. So this means it would provide self-service capabilities so that the teams don't depend on ops teams. Self-service doesn't mean there's no governance around that. The platform needs to automate the permissions, the policies, the requirements, and the guardrails around this platform so that when the developers self-serve, they actually do it in a safe and a compliant way. So, for example, an internal developer platform might have an example of, create a new service button, which behind the scenes would set up the repo, the CI, the cloud infrastructure, the observability would be implemented, everything that is needed in accordance to the company's guidelines and standards. The developers would simply, for example, fill in the needed parameters, like, the region for that service, the service name, which database that they will be connected to, and the platform would take care of the rest. Similarly, for an SRE engineer, for example, they will be able to use ready-made templates to create their dashboards instead of doing that manually. So it's not just for the developers, it's also for SRE teams and any team that needs to automate the operational toil in the company. And the platform does that by abstracting away the noise and the complexity and exposing only what is needed for the development teams to accomplish their tasks. But it doesn't force them, and it doesn't take the control away. So to define the right level of abstraction, it is very crucial for the platform team to make their platform useful and encourage their team's adoption. And how do they achieve that? They achieve that through what we call the golden path. These are like standardized workflows, pre-approved also workflows, that would reduce the decision-making and would reduce the cognitive load, promote trust also, and promote frequent and faster deliveries. So the developers, for example, wouldn't ask too many questions and wouldn't take like different roads to actually go to production. Golden paths, however, should be optional. You shouldn't force your teams to use them if it doesn't make sense to them. They should also be flexible and extensible to actually create the path of least resistance and also make sure that they could accommodate future use cases, because your platform is something that evolves through time. That said, they also should be unique to the reality of your company, to its size as well, and the team's pain points, the team's maturity. So please don't build platforms that your teams didn't ask for or your teams don't actually need, and also don't copy from other companies. I've seen this a lot. A lot of companies would actually copy the same blueprint from, I don't know, Netflix or Airbnb and try to apply it to their reality, which almost always not a good idea. And sometimes your organization doesn't even need a platform, or maybe doesn't need a platform yet, because it would depend, as I said, on the maturity of your teams and the size of your company. Another thing that platform engineering would allow is to shift security left and enable practices like DevSecOps and compliance as well. So the platform does that by embedding built-in policies, guardrails, and automated processes by design so that the teams don't have to think about how to implement them, and you wouldn't be chasing security champions to actually implement your security checks, making the implementation easier and making the compliance more confident and more reliable. It also increases quality. So, well, this is the kind of things that would make deployments on Friday possible, for example. I'm not saying you should do that, though. Of course, all these efforts and all these guidelines should be intuitive and should be user-friendly for the development teams or any teams that is using the platform. So this is where developer experience becomes important when creating a platform vision, as the platform is your only single point of entry to your teams. It centralizes the knowledge, the processes, and the tools, and should enforce consistency. So this is where tools like Backstage, for example, become handy to provide that single entry point, but you can also build it yourself, of course. So what I'm trying to say here is that the platform or platform engineering is not just technical. It's delivering an experience to your teams or to your users, along with trainings, how-to guides, and a UI as well. We saw the talk just before this one about the platform UI, and all the things that would make the developers happy and productive. So it's important to track your users' satisfaction through metrics. That could be metrics like developer satisfaction, onboarding time, time to deploy, adoption metrics, and treat your platform as a true product. So successful platforms would treat their developers as customers. They will conduct user research, for example, beta testing with pilot teams, embedding feedback, for example, in every release, just like a true product, basically. So the real mission of a platform is to remove friction and support a smooth delivery flow. But as we know, flow does always require an organizational design. I mean, we're all here today to talk about platform engineering and team topologies. This is where the platform team from Team Topologies comes in handy as a dedicated team that would build internal platforms as a product to support the flow and to reduce the cognitive load by serving self-service tools and knowledge to your teams. So I think it's safe to say by now that platform engineering is actually an enablement to DevOps at scale, and that DevOps is not dead, as many of you say. But that sounds very perfect on paper, right? Unfortunately, the reality of platform engineering today is not as perfect as that. It is a new concept, so as any other new concept, it will require a lot of trial and errors, and anti-patterns will also emerge. So some of the anti-patterns I observed in my experiences are on 3 levels: organizational, technical, but also strategic. Let's start with the technical. So I said earlier that platforms would abstract away complexity, but building abstractions is not very intuitive, as some of you might know, and finding the right level of abstraction is very tricky. So if the abstraction is too rigid, it will not fit all your platform use cases or your future use cases. Over-opinionated abstractions will lock your teams into narrow paths or patterns, and when a new use case emerges, the developers will start to bypass the golden path and create what we call the shadow path or the shadow IT. And if it's too flexible or if it's too broad, it becomes hard to maintain and turns into an explosion of custom variants and configurations, and it will lose the benefit of standardization. The next anti-pattern that I think of is when we see the platform as one-time project or a one-time product and not as an evolving one. So platform team would get stuck in what we call the day two hell and would be stuck in managing day-to-day operations instead of actually implementing new features or new developments of the platform. I've seen this happen for multiple reasons, but I think the most obvious reason is that we treat the platform as anything but a product, and we have an approach of creating a roadmap that has features in response to requests or a reactive approach between the platform team and the developers. And this is where the role of product ownership is very important in platform engineering, because the platform product owner is a new role, and it requires a strong knowledge of both product management and the technical domains of platform engineering, which is quite hard to find actually today. So companies usually would have one or the other, so neglecting one domain versus another. I was a platform lead recently for 2 years, and sometimes I think I would say I felt like I had 3 heads or 3 personalities. I had to define the architecture and the implementation of the platform. I had to prepare for the backlog, to talk to management about the roadmap and the return of investment of the platform, talk to my users, the developers, about their needs and prioritize them, which was not very sustainable, neither for me or to the teams. So I think a good approach here would be the famous product trio, so the product manager, the engineer, the designer, to fill any gaps in your platform vision. The most ironic anti-pattern that I've seen would be labeling your existing IT team or IT support team as a platform team and keeping the legacy ways of working with the silos and people filing tickets to IT help desk, basically. Or sometimes it would be also having multiple fragmented initiatives for platform engineering that would span multiple departments. That's also a way to duplicate effort and lose the vision of your platform engineering initiative. So if your platform org chart mirrors your legacy silos, you actually didn't break the Conway's law, you basically rebranded it. The opposite of that would be having the platform team as a gatekeeper. So literally everything that the teams need would still need to go through the platform for approval and decision making, introducing a powerful silo for the teams, and undoing everything that DevOps promised us with autonomy. So the platform teams becomes the single point of failure for anything outside of the golden path, and the backlog becomes huge and slows down everyone basically around it. So if your new features would always depend on the platform team, you created a dependency and you didn't create a self-service platform. Building a platform for the sake of the tech itself is not a good idea either. So if your teams are forced to use these platforms or don't understand why and how to use it, they will probably not use it at all. So You should ask your users what they need. You should understand their pain points. Similarly, the platform team or the platform lead would always describe the platform value in technical terms. And believe me, I made this mistake myself. We talk about latency, pipelines, uptime, instead of linking them to the business outcomes. So faster time to market, for example, reduced incident cost, or improving productivity, for example. If you do that, the business stakeholders would view the platform as a cost center and not an actual innovation driver. So if you still need to convince your business that your platform has value, you haven't actually connected it to their goals. So we still have few seconds. Platform engineering is about enablement, so it gives your teams the right tools, the right knowledge to safely run their products in production. It's an extension or an evolution to DevOps, so DevOps is not dead. It's what makes DevOps possible at scale. It enables us to build and run, and transforming you build it, you run it, more into you build it, you can run it safely and confidently. Thank you, everyone, for listening.